Good morning, guys. Today we are going with next problem on trusses. That is now problem number 2. Now just read the problem. Determine the nodal displacement. Determine the nodal displacement, stresses in the elements and reactions at the fixed support for the truss member shown in figure. Consider Young's modulus equals to 70 GP and A is equals to 0.01 meter square. 0.01 meter square. All the units are given in meter, that is area is given in meter. Now this problem what I will prefer is I will go with all the dimensions are in meters. Okay. Now for that first I want to locate the number of nodes. First node. Now I told you always it should be in first quadrant. That means if you take first quadrant, my first node will be here, node 1, node 2 and node 3. Now node 1, node 2, node 3. Now if you take the coordinate values generally here, first node I will take this node as 0, 0 because it is at origin, particular origin point. If I take this is x and if I take this is y, this is x axis and this is y axis. Now then generally here the first node will be at 0, 0 that is at exactly at origin. Next second node, say it is 1 meter, that is in x direction, 0 in y direction. Similarly this is x is 0, 1. Now first initially we written all the values. Now just observe now. I will just represent all the nodal data here. First step is what? Nodal data step 1. What is the node location? What is x coordinate? 0. Y coordinate is 0. What is node 2? What is x coordinate? X coordinate is 1. Y coordinate is 0. Next node 3. What is x coordinate? X coordinate is 0 and y coordinate is 1. Now apart from that, if you observe element numbers, now I will take in this manner, that is in counterclockwise manner. That is no element number 1 is 1 and in between 1 and 2 element number 1, in between 2 and 3 element number 2, and in between 3 and 1 element number 3. That means 3 elements will be there. 1, 2, 3. The difference is previous problem we have only 2 elements. This problem I am going to use 3 elements. Okay, 3 elements problem. Now if you take first element, element number 1, that is node 1 and 2. Node 1 will be your initial node, that is 0, 0. And next final node will be node 2, that is 1, 0. Similarly go to node element number 2. Element number 2, initial node will be 2, that is 1, 0. And final node will be 3, that is 0, 1. Then element number 3, initial node will be 3, that is 0, 1. And final node will be 1, that is 0, 0. That means you should first understand why initial node, final node is required. I told you, so if you want to calculate length of the element LM, you require formula x2 minus x1. That is x2 minus x1 is nothing but final node minus initial node divided by length of the element. Because of that concept, first you should know which is your initial node, which is your final node. That will clearly define you which is x2, y2, which is x1, y1. Always initial node will be your x1, y1. Final node will be your x2, y2. Because of that concept, we should require this. Now after this, now nodal data is written, element complete data is written, but I want to calculate LE, L and M. To calculate that, now I will go to this one. Now first I am representing element number 1. If you observe here, what is element number 1? This will be element number 1. Element number 1 and 2, that is node 1 and 2. Initial node is 1, final node is 2. Now how to calculate this length of the element? Substitute what is your x2? x2 is 1 minus 0 whole square plus, then what is y2? 0 minus 0 whole square. That means length of the element for this element is 1. Length of the element is 1. Now you got length of the element, then x2 minus x1. What is x2? x2 is 1 minus 0 divided by 1, then L will be equal to 1. What is y2? 0 minus 0 divided by 1, that is 0. That means your L will be 1, M will be 0. That means L square will be 1, M square will be 0, LM will be equal to 0. This is how you should calculate your L square, M square, LM. Now after calculating your LE, L and M, represent here. That is length of the element is 1, L is 1, M is 0. That first element is over. Now similarly take your second element. Now observe which is initial node. For second element, initial node is 2, final node is 3. That means x1, y1 will be 2 and x2, y2 will be equal to 3. That means node 3 will be your x2, y2. Now substitute same thing. Now what is x2? x2 is 0 minus 1 whole square plus y2 is 1 minus 0 whole square. If you calculate, this is square root of 2 you are going to get 1.414. 1.414 is the length of the element LE. Then if you got LE, now calculate what is x2 minus x1. x2 is 0 minus 1 divided by 1.414. You are going to get minus 0.717. Just check it. Minus 1 divided by 1.414. 1.414. Yeah, 0.707. You're going to get 0.707. 0.707. Similarly, now if you check this, that is y2 minus y1. y2 is 1. y1 is 0. Divided by 1.414. You're going to get once again 0.707. That means 0.707. 0.707. What is L square? L square means minus 0.707 square. If you calculate, you're going to get 0.5, because minus and minus it will be plus 0.5. L into M, it is L is minus 0.707, M is 0.707. It is once again 0.5, but it is minus 0.5. Then M square is 0.5. That means 0.5 minus 0.5, this one. Now just represent your values here. 1.414 minus 0.707, 0.707. You got it now. Then after that, third element. Go to third element, just check it which is initial node. Initial node will be 3, final node will be 1. What is meant by initial node here? x1, y1 will be 3, x2, y2 will be equal to 1. Now calculate once again. What is x2? x2 is 0 minus 0 whole square plus 0 minus 1 whole square. If you calculate it, you are going to get 1. 1 is the length of the element for third element. Similarly, what is x2 minus x1? Now calculate. x2 is 0, x1 is 0, divided by length of the element is 1. You are going to get L will be equal to 0. What is M? y2. y2 will be equal to how much? 0. y1 will be equal to 1 divided by 1, that is minus 1. Answer is minus 1 here. Now you got L, M and length of the element. What is L square? L square is 0. M square is plus 1, because minus 1 into minus 1 plus 1. Lm is equals to 0. Now you got it. What is L square? L square, M square and Lm. Now this is how you should calculate all the three element requirements. Why I calculate L square, M square, Lm? Because it is a requirement in your elemental stiffness matrix. Why I calculate Le, Lm? Because if you want to calculate your elemental stiffness matrix, L is required, L square is required, M square is required, Lm is required. Similarly, okay. Now write your third element. What is the length of third element? Third element length is of 1. What is the value of L? L is 0. M is equals to minus 1. Is it correct? Yes. Okay. Now see, I had calculate first. This is your initial step. See, always if you want to solve a problem, first these two tables should be perfect. If these two tables you don't make any mistake, 99% always your problem will be correct. 90% always your problem will be correct. Now after doing this, next step. What is the next step you should go? Go for calculating your elemental stiffness matrix. What is the elemental stiffness matrix for truss? AE by L, L square, Lm minus L square minus Lm. I think you know how to remember this. L square, Lm. This you can use it. Okay. Then first element. See what is first element? 70 into 10 power 9. 70 into 10 power 9 is your Young's modulus. Okay. 0.01 meter square is the area. And 1 is the length of the first element. Because I am calculating your first element. 1, 0, minus 1. Because L we know 1. L square it will become minus 1. Sorry, minus L square means minus 1. Then substitute all the values here. L square, Lm. See, you know already you calculated. What is L square? L square is 1. M square is 0. Lm is 0. That means L square, M square. That means 1, 0, 0, minus 1, 0, 0, 0. You can finish this. Now after this calculated, you are going to get 10 power 8 common. Keep 10 power 8 common. What are the remaining values there? Send it inside. This is your first elemental stiffness matrix. Now similarly calculate your second elemental stiffness matrix. What is the difference in second element matrix? Length of the element is different. Now calculate length of the element. Substitute your L square, Lm, all the values here. You are going to get a second matrix, that is second element matrix, that is 2.45 minus 2.45 minus 2.45, 2.45. Similarly, if you repeat it, you are going to get this. Okay, this is your second matrix. What is third matrix? Third matrix also it is a repetition, correct? Now substitute all the values. Ke3. What is Ke3 now? Area is 0.0 because area is not changed because common area is given for all the elements. Young's modulus is a common. If a different area, Young's modulus and area is given, you should use different. Like your previous problem, have two different areas. I want to use the two different areas for that. That means element 1 is different areas, element 2 is a different area. That is also possible. I had shown it in the previous problem. But in this problem, area is common, Young's modulus is common, use this. Okay. Then substitute your Lm, every value here, L square, Lm, everything. Now multiply. What is the value you are going to get? You are going to get 7 into 10 power 8. Keep 10 power 8 outside. Substitute all the values. Now just observe one thing. See first element. What are the nodes for first element? So nodes are 1 and 2. What are the displacement element 1 and 2? 1, 2, 3, 4. That means Q1, Q2, Q3, Q4. I represented 1, 2, 3, 4, 1, 2, 3, 4. Similarly come to second element. What are the nodes for second element? 2 and 3. 2 and 3. What are the displacement? 3, 4, 5, 6, 3, 4, 5, 6. Now come to next element. Next element what? See it is connected at node 2 and node 3. See node 1 and node 3. Because of that, what are the displacement we are getting? 5, 6, 1, 2. You may ask me why 5, 6, 1, 2. Because initial node I had taken as a 3, final node I had taken as a 2. Because of that, I want to represent like this only. What is where I started? Third node. That means first two values are representing your third node. That means 5 and 6. Last next two values are representing your 1 and 2. That means initial node and final node. That should be very, very clear. Then after completing this, next step is you should make a global elemental stiffness matrix. Next step is you should make an elemental stiffness matrix. Now how to make your elemental stiffness matrix? Just observe here 1 1. Now observe how many values of 1 1 is there. See in matrix 3 I have 1 1, that is 0. See if you come to matrix this one, there is no 1 1 value in matrix 2. But matrix 1 I have 1 1. What is that value? 7. That means here I am going to get 7 plus 0. Are you getting it? Because I have value of A11 in two matrices. One is element number 3 matrix and one more is element number 1 matrix. Element number 1 matrix. Next after this, what is next? 2 1. 2 1, just observe here 2 1. 2 1 is 0. That means 2 1 0. Okay, 0. Then if you take your 2 1, in this matrix it is not there. If you take this 2 1 is there, that is 0. That means it is 0 plus 0 0. Now come to next one. 3 1. Whether you have 3 1 in this one? No 3 1. In this one you have 3 1? No 3 1. But in this one you have 3 1. What is that 3 1? Minus 7. Minus 7. 4 1. Check it for 4 1. I think it will be 0. If you check it, it will be 0. Then 5 1. Check it 5 1. See 5 1. Yeah, 0. 6 1 0. Got it? This is your first row. Repeat same thing. What is the next thing? First row should be equals to first column. Directly I am writing 0, minus 7, 0, 0 and 0. Over. Now come to next one. 2 2. Where is 2 2? Just check it here. 2 2 will be 7 here. 2 cross 2, that is 7. Next one is 2 2 here. 2 2 is 0. That means 7. Because in this one there is no 2 2, 7. Once again it is 7. Now check 3 2. 3 2. 3 2, I think in this one there is no 3 2. In the first, that is 2 both the matrices. That is element number 2 and element number 1. Element number 3 is not related to 2. Because of this 2 2, if you check it, 2 2 0. 3 2 is 0. 4 2 is 0. That means here 0, 0, 0. Then check it for 6 2. 6 2, I think you have 5 2 here. You have value here 5 2, that is 0. 6 2 you have minus 7. See 5 2, if you check it anywhere you have 5 2. 5 2 is not there. That means what is the value here? Minus 7. Minus 7. Next, second row should be equal to second column. Retrace this values. What are the values remaining? It is there 0, 0, minus 7. Now what is the next value required? 3 3. Where is 3 3? Check it. Any 3 3 is there? No. Come to this matrix. 3 3 is there? Yeah, 3 3 is there. That is plus 7. What about this one? 2.45. 7 plus 2.45. Write it here. 7 plus 2.45. Next 4 3. 4 3 is there? Check it. 4 3. 4 3 is 0. Here 4 3 is minus 2.45. Anywhere 4 3 not there. That is minus 2.45. Minus 2.45. 5 3. 5 3 is not there in this matrix. 5 and 3 it is also not related here. 5 3 it is there. That is minus 2.45. Minus 2.45. Then you are going to get last value, that is plus 2.45. 6 3. Check it. Now similarly repeat. Next one is next 4, that is this row should be equal to this column, means the up to 3 values we have written, remaining 3 values here it is there. 2.45, 2.45. Next value, what is the next value? 4 4. Check it. Where is 4 4? 4 4 it is there, that is 2.45. Here 4 4 is there, 2.45. What is 4 4? 0, that is 2.45. 2.45. Next 5 4. Any 5 4 value is there in this one? I think here it is not there. 5 4 it is there. What is 5 4? It is 2.45. 2.45 minus 2.45, that is 6 4. If you check it, minus 2.45. Then once again repeat these two. 2.45 minus 2.45. Then what is the next one? 5 5. Where is 5 5? 5 5 is 0. Check in this one, there is no 5 5. In this 5 5 is there, that is 2.45. 2.45. Then what is 6 5? 6 5 is 0. 6 5 is minus 2.45. Minus 2.45. Minus 2.45. Then what is the last value? See, this 2.45 it will come here. Only value left is 6 6. If you check it, 6 6. 6 6 it is 7. 6 6 it is 7 here. Then 6 6 here. 2.45. 7 plus 2.45. Now right here this is 7 plus 2.45. Now this is called formulation of global stiffness matrix. See how I added. You just observe one thing. Wherever connectivity is there, always there is a 2 numbers at that particular nodes. For example, if you see in this problem, what is the connectivity? Where is connectivity is present? Just observe connectivity is there at node 2. That means here there is always generally 3 and 4. That means 3 comma 4, because 3 3 and 4 4 you have an addition values here. If you observe here 5 6 means it is a connectivity between element number 1 and element number 2. Generally there is a addition will be occurring at node 3 and node 2. Okay, that is what the concept. See, this is your formulation of your global stiffness matrix. See, after formulating your global stiffness matrix, next step is, what is the next step? You go for formulating your global nodal displacement. Global nodal displacement vector. You go for nodal displacement vector and force vector. Nodal displacement vector and force vector. Now you know how many nodes are there? 3 nodes. At each node, how many displacements are there? 2 displacements. Because of that, your order of the matrix is 6 cross 6. Now, how many displays you are going to get? At each node, 2 displacement: Q1, Q2, Q3, Q4, Q5, Q6. 1 and 2 belongs to node 1. 3 and 4 belongs to node 2. 5, 6 belongs to node 3. Similarly, I told you in this problem, you only get point loads. There is no any body force and surface force. Because of that, it is neglected. Directly, we can write global force vector into point load vector. What is point load vector means? F1, F2, F3, F4, F5, F6. Why you written 6? The reason is very simple. 3 nodes are there. I have 3 nodes. I can apply the forces in this manner: horizontal force, vertical force, horizontal force, vertical force, horizontal force, vertical force. Node 1, node 2, node 3. Now, if you observe this one, at node 1, what is the force acting at node 1? Just observe your problem. What is the force acting horizontal at node 1? Because completely fixed, there is no any force is acting. 0, 0. That means horizontal force is also 0. Vertical force is also 0. That means 0, 0 at return. Horizontal force is 0. Vertical force is 0, 0. Now come to node 3. Node 3, if you observe, one force is acting horizontally. That is, see, this is your positive x. It is acting opposite to it. That means it is horizontal force. That is 3. At 3, minus 100 Newton. 100 Newton is that. Next 4, because there is no any vertical force in the problem. Because at node 2, 0. Then go to F5. See, if you observe node 3, what is the horizontal force acting? There is no any horizontal force at node 3, but vertical force is acting, that is in positive direction, 200 Newton. That means F5 is 0, F6 is 200. If you observe, F5 is 0, F6 is 200. Now this is what your formulation of global nodal displacement vector and force vector. After formulating this, next step will be your, what is next step? Combined. That means use your continuum equation. What is that continuum equation? K into Q is equals to F. Now represent your K. Already we have done it there. Done it in your previous section. So keep your K values completely. This is your global vector. Then global displacement vector Q1, Q2, Q3, Q4, Q5, Q6. 0, 0, minus 100, 0, 0, 200. Now this is your next step. That means continuum representation. After representing your continuum, what is the next thing? Apply your boundary condition. What is boundary condition? I told you we are using elimination method. See, elimination method, if you are observing, come to your problem first. Observe elimination method. What is elimination method? Says that, see whatever the nodes fixed, how many nodes are fixed, or whatever the nodes are fixed. Say if you fixed node, how many nodes are fixed here? Node 1, node 2, node 3 are there. If you observe node 1 is completely fixed. That means what is completely fixed means Q1 is equals to 0, Q2 is equals to 0. Why Q1 equals to 0, Q2 equals to 0? Because I have only 2 displacement, I can get it. One is Q1, one is, that is horizontal displacement Q1, vertical displacement Q2. That means over. Now come to here. If you observe this, here how many displacement? You can get Q3 and Q4. But if you observe this, a roller support is given. What is a roller support here? Say roller is given in this direction. This direction roller is given means it can easily travel in x direction. That means Q3 is not equals to 0. But if you observe, Q4 is equals to 0. That is what the condition that will be given at node 2. Now similarly go to node 3. What are the displacement node 3 we represented? Q5 and Q6. Now how is the roller is given? Roller is given in the vertical manner. That means it will travel in upward direction. That means it will be Q6 will not be equals to 0, but Q5 will be equal to 0 because it is fixed. That means roller is given, you should see which direction the roller is given. Based on that, you should decide. That means if you observe now, how many displacements are now? Q1, Q2 0, Q3, Q4 is 0 and Q5 is 0. That means if you bring here, I can write that as per the given problem, Q1 and Q2 are 0 because completely node 1 is fixed. Node 1 is fixed. In node 2, only Q4 is 0 because he has allowed a roller in the x direction. Then node 3, Q5 is 0, he is allowed roller in the y direction. That means what are the displacement 0? Q1, Q2 equals to 0, Q4 equals to 0, Q5 equals to 0. What is the meaning of this? Now, you should eliminate the corresponding rows and columns of this particular displacement. What are the particular displacement? Q1. Q1 means which row? First row, first column. Then what is the next one? Second row, second column. Then after this, what is next? Fourth row, because Q4. Fourth row, fourth column. Next, what is the next one? Fifth row and fifth column. Now observe, what is the remaining values are there? Just write your remaining values. 10 power 8, 9.45 is the remaining value there, 2.45 is there, then after this 2.45 is there, okay, then after that 9.45 is there, 9.45 is there, is equals to, what is the value here? Minus 100 and 200, minus 100 and 200, that is your forces. Now, sorry, here I missed something, I will write here, what is that displacement? Q3 and Q6 is equals to this. Q3 and Q6 equals to this. Now if you solve these two equations if you solve it, you are going to get a solution, that is Q3 is equals to minus 7.247 in 10 power minus 7, 2.56 in 10 power minus 7 in meters. Why meters? Because I am using all the dimensions are in meters. That's why I used even Young's model. If you observe 70 into 10 power 9. Why 70 into 10 power 9? 70 GPa. What is 70 GPa? 70 into 10 power 9 Newton per meter square. Now this is how you should calculate your displacements. Sometimes in problems they ask you only determine the displacement, you can stop at this particular point. If further is given, determine the stress, reaction, all those things, you should further, you can proceed. Now come to next step, how to determine your stress. Directly I am explaining stress, and you know how to calculate your strain also. Okay, directly I am taking your stress. Now E by LE into E by Q. What is E by Q for this truss element? E by LE minus L minus M LM. Now what is E by LE? E is 70 into 10 power 9. What is the length of your first element? 1. What is the minus L value? Minus L means that is first element. What is L? L, you know that L will be equal to 1. That is minus 1. L will be equal to 1. M will be equal to 0. That is minus 1 minus 0. This is L will be equal to 1, 0. Then what is Q1, Q2, Q3? Q1 is 0. Q2 is 0. Q3 is minus 1.724 in 10 power minus 7. Q4 is 0. Now if you solve this, you are going to get a stress at minus 12.06 into 10 power 3 Newton per meter square. This is for this one. Similarly for second element, what is second element? Same thing, repeat it, and your Young's model is same. 1.414 is the length of the element. Then what is L value? L value is minus 0.707 means 0.707. M is minus 0.707. That is L means, once again, what is L? Minus 0.707. Okay. M is 0.707 into Q3, Q4. What is Q3? Q3 is 1.724 in 10 power minus 7. Q4 is 0. Q5 is 0. Q6 is 2.56 into 10 power minus 7. Why I had taken Q3, Q4? Because second element, the nodes are belongs to what? 2 and 3. 2 and 3 in your problem. This is the answer what you are going to get if you solve it. Okay. Then what is third one? Same thing. 70 into 10 power 9. 70 into 10 power 9. Then Young's model length of the element is 1. What is L value? L value, if you observe, L will be equal to 0. M will be equal to minus 1. That will become plus 1 here. That is 0, minus 1. What is Q5? Q5 is 0. What is Q6? Q6 is 2.56 into 10 power minus 7. Minus 7. Then 0, 0. Because Q1, Q2 are 0. If you solve it, you are going to get 17.92 into 10 to the power 3 Newton per meter square. 17.92 into 10 power 3 Newton per meter square. That is your next one. And then after finishing this, next you should calculate what is your reaction. Now how to calculate your reaction? Take your eliminated rows. That means first row is eliminated. Now first row if you eliminated, take the values. What are the values you are going to get? 7 into Q1, 0 into Q2, minus 7 into Q3, you are going to get this value. Now if you observe, Q1 is 0, already I know. Q2 is 0, already I know. Then what is Q4 is 0, correct? Then Q5 is 0. Remaining values will be only the 0 into Q6 is 0. This is also 0. What is the remaining value? F1 is also 0. What is the remaining value? 10 power 8 into minus 7 into what is Q3? Minus 1 point, just observe 1.724 into 10 power minus 7. Minus 1 point, you are going to get 120.68 Newton. This is what the answer you are going to get it. Similarly, come to next one, R2, because R2 is also eliminated. 0 into anything is 0. 7 into Q2 because Q2 is 0. Q3 is 0 into anything is 0. 0 into Q4 is 0. 0 into Q5 is 0. Then F2 is also 0 because force is not applied. Then what is the only value left? 10 power 8 minus 7 into what is Q6? Q6 is 2.56 into 10 power minus 7. You are going to get 179.2 Newton. That is at R2. Now similarly repeat your R4. How to calculate? Because eliminated row is fourth row is eliminated. 10 power 8. 0 into Q1, 0. 0 into Q2, 0. Minus 2.45 into Q3. What is Q3? Q3 is minus 1.724 into 10 power minus 7. then Q4 is 0 because eliminated, Q5 is 0, then the value is minus 2.45 into, what is the value of Q6? Q6 is, Q6 value is 2.56 into 10 power minus 7. Similarly, even this force is also 0. You are going to get 20.42 Newton. 20.42 Newton. Now repeat the same thing above. If you observe R5 and R4 are similar, minus 2.45 into 1.724 into 10 power minus 7, minus 2.45 into 2.56 into 10 power minus 7. Similar, why? Because Fi is 0, just observe 0, 0. Then Q3 is there, Q4 is 0, Q5 is 0. If you observe minus 2.45 into Q3, minus 2.45 into Q3, minus 2.45 into Q6, same value you are going to get. Even if you observe the problem, you are going to get, see, 120 horizontal force is applied is 100 Newton. Here 120 is there. Similarly, this is minus 20 means almost it is equal to 100. If you come to this, R2 you applied, that is vertical force you applied is plus 100, plus 200. If you observe here, what is the reaction? You should get minus 200. Just add these two, minus 170 and minus 20, almost near to 200. This is how you should solve your problem. Got it? Thank you.